going to stay the same and our steps are going to stay the same, but now we're going to have absolute value bars show up in the equation. Okay, so we're going to start super simple. So let's say we have something like the absolute value of x plus 2 equals 10. Now, the reason why absolute value sort of didn't fall into our little shortcut PEMDAS quick order of operations things is because absolute value bars kind of stick and hold tight. It's not like parentheses where we can sort of distribute and get rid of the parentheses and then just go from there. Those absolute value bars hold really tight. So what our objective is going to be is sort of to go through that inverse process twice. Once for the stuff outside the absolute value bars, and then once for the stuff inside the absolute value bars. Okay, so our first objective is going to be to isolate the items inside the absolute value bars. So here's the stuff inside the absolute value bars, and we want to isolate it. What does the word isolate mean? Get it by itself. So what is sitting outside of the absolute value bars over here that we still need to move? A plus 2, right? And if, I mean, other than it shines on my hand, but pretend that it's not, right? If we couldn't see what was underneath here and it was just x, just solve it exactly like what we would do. We would subtract 2 from each side. Never put it away. And so these would cancel. And that would take us here. Now, we need an inverse operation to actually get rid of these absolute value bars. And our inverse operation for absolute value is that we actually want to take the positive and we want to take the negative. Because if we are saying that absolute value technically has a definition of our distance away from 0, how many numbers have a distance away from 0 of 8? 2 of them, right? One of them is positive 8, and one of them is negative 8. So we are going to have to consider 2 separate equations at this point. And to get those 2 separate equations, we are going to break this up into 2 things. So we're going to go 2 options here. Okay, option 1 is that we will have to consider the fact that x could be 8, or we also need to consider the fact that x could be negative 8. Good catch.
So the water.
So if we're looking at this point there is nothing else to solve and we have 2 answers. X can be 8 or x can be negative 8. How can we check and see if we're correct?
Plug it back in.
Plug it back in. So if we were to plug this back in, how many values would we have to plug in? Not 1 value. 2, right? Because how many answers did we get? 2 of them. So if we plug in positive 8, what is the absolute value of 8? And 8 plus 2 is 10. Then we'll have to start over and we'll have to plug in negative 8. What is the absolute value of negative 8? And 8 plus 2 is, right? So they both work. There are 2 answers in this problem. Okay? So let's look at another one. And then we have the absolute value of x minus 4 equals 24. Okay, doing the same thing. So if we look at this and we go by our rules, right, we said the first thing we're going to do is get rid of the stuff outside of the absolute value bars. We're going to isolate the absolute value bars. So what do we need to move? The 3. How is that 3 attached? Multiplication. Now, here is where I said this before, you cannot distribute that 3. Absolute values are not parentheses. That 3 does not go inside there. So how do we undo multiplication? Division. So I'm going to divide each side by 3. What am I left with over here?
Absolute value of x minus 4.
Okay, so I purposefully made this equal the same thing because the idea is exactly the same. How many numbers have an absolute value of 8? 2 of them. So we have to consider both of them, which means we need to consider the fact that x minus 4 could equal 8, or x minus 4 could also equal what? Negative 8. Because what is the absolute value of negative 8? 8. And what is the absolute value of positive 8? 8. And yes, you are then looking at this correctly when my students go, you mean I have to solve 2 equations now? Yup, you sure do. So now you have to solve this as 2 separate equations using our rules of equations that we already know. Okay, so we're undoing subtracting 4 by adding 4. Be careful because they are not always one positive and negative option. So we get x equals 12 and x equals negative 4. It's totally fine to write it this way and circle your answer, but oftentimes what you'll see in the math world is this. Right? X can be 12 and negative 4, just a comma in between them. Either way is fine. There isn't a right or wrong. There isn't necessarily a more preferred. You just maybe see that second option more often. How do I feel about that one? So, okay, so far so good? Is that a question? No, that was a structure. You're fine. And then how about this one? Absolute value of 2x minus 7 plus 12 equals 5. What do we think we want to do first here? Do we agree with subtracting 12?
Mm-hmm.
Right, I would agree. So we subtract the 12. What do we want to do next? What has been our next step?
It's a negative.
How do we get rid of the absolute value? We went to both options because we said 2 numbers have a distance from it, 0 of 8. How many numbers have a distance from 0 of negative 7?
0.
Why none of them?
Because it's a negative.
Because what did we say before lunch? Can absolute value ever equal a negative number? No, so is this mathematically possible?
No solution.
This is a no solution. Right? The absolute value of something cannot be negative. Period. Yeah, so it doesn't matter if negatives show up other places. It's okay that I got a negative here. Okay, it's okay that there's like subtraction involved. But what we can't have is when we get the absolute value isolated, that being equal to a negative number, because you all told me absolute value cannot be negative. value of 2x minus 8 equals 4. Kate, what do you want to do first?
Oh,
Oh, you were going to say something else?
I was just gonna guess the answer.
No. What do you want to do first?
Subtract the 4.
Subtract the 4. Are we okay with subtracting this 4?
Yep.
Okay, so now how many numbers have a distance from 0 of 0?
1.
1. Right? Could I really split this into a positive 0 and a negative 0?
No.
Why not?
No, one.
Right, there's not really a positive or a negative 0, so I guess you could, but then you'd just be doing the same thing twice. So this one we don't need to, and 0 is our sort of weird option here, so the absolute values just kind of go away. Because there's only one option of a distance of 0 from 0, which is 0. And we're just left with something to solve.